All right, the topic of this lecture is solid waste and hazardous chemicals. Our agenda for this lecture is to distinguish municipal solid waste generation, composition, and management in different contexts, to identify the different types of waste management approaches in terms of the least and the most preferred, according to the US EPA hierarchy of waste management, and also to define environmental justice in terms of its principles and to apply it to decisions that need to be made during the engineering design process. So in the United States, most of the waste produced goes to landfills. We've more than doubled the amount of trash that each American produces each day over the past 50 years. And as you can see, the breakdown of the waste production in the US includes mostly paper, food, and yard wastes, with a large percentage of plastics as well, followed by metals, rubber, leather, textiles, etc. Much of the increase in our waste production is owed to the increased use of disposable products nowadays. But the amount and the composition of municipal solid waste, as well as the way that it's handled and treated or managed, is very different between different countries. So in the United States, local governments have the primary responsibility for collecting and disposing of municipal solid wastes. And this is paid for by households through their taxes, by a pay-as-you-throw fee, like based on the amount of trash thrown away, and also with private collectors that send bills to households that receive collection services. Up until the 1960s, municipal solid waste in the US was just burned in open dumps for the most part. So the incineration of solid waste is something that's practiced throughout the world still to this day. It does reduce the volume and the quantity of waste, but it causes a lot of problems with regard to air pollution. Open dumps and incinerators were phased out and replaced by landfills after the 1960s. However, open dumps are still found in many areas throughout the world. Over the past 10 to 20 years, however, the use of landfills and combustion have both declined as we move towards newer, more sustainable methods of solid waste management. Now let's contrast the situation in the US with a country like Sweden. In Sweden, less than 1% of the trash ends up in landfills. There's active promotion of waste reduction and recycling. And for the waste that is produced, waste to energy power plants are using it as a fuel to burn, which generates electricity for 250,000 households. The air pollutants or the air emissions that are produced by these facilities are treated with air scrubbers, and the ash, which is left over after burning, is also treated to remove gravel, metals, and other contaminants. Sweden actually takes in trash from other countries, and they pay Sweden to take their trash, and then Sweden goes and turns it into electricity. The amount of solid waste production globally has drastically changed during the COVID-19 pandemic. And there's been multiple publications in the aftermath of COVID-19 that document this increase in pollution in plastics and single-use disposable materials. It's having an impact on the global plastic waste footprint already. And even just something as simple as face masks, disposable face masks, are causing now threats to the marine environment. All right, so it's easy to see here how aspects of waste management are connected to a lot of other parts of life, like health and the environment and economic productivity. Between regions, there's a big difference in waste generation. So if we just look at the total waste generation by income group, there's been a projected increase in the amount of waste that's going to be produced by lower middle income countries. As more countries develop from the lower income bracket into the lower middle income bracket, that waste production is expected to drastically increase by 2025. In terms of per capita waste generation, high income countries and upper middle income countries still generate the most amount of waste and are projected to continue to generate the most amount of waste of all countries. The composition of waste also drastically differs between regions. So in lower income countries or regions, most of the waste tends to be organic, with a smaller fraction being plastic, glass, metals, etc. In higher income countries, more of that waste tends to be paper, plastic, larger percentages of paper waste, and smaller percentage of organic waste. There's also a small amount of waste which is considered to be hazardous or toxic, and that waste must be managed in very particular ways in order to protect the public health. This graph here shows the toxic release inventory in the United States, just showing that the amount of toxic wastes released in the United States have not really changed so much throughout this decade seen here from 2003 to 2013. And the sources of those toxic releases are coming from metal mining industry, electric utilities, chemical industries, and other sectors, as you can see here. So when it comes to toxic and hazardous waste, the hazards that are, or the risks that are produced for members of the public who might become exposed to that waste have to do with hazard and exposure, or the dose. So the dose is directly linked to the response or the effect. And there's a threshold level in the dose response relationship. In other words, organisms, including humans, can handle some level of exposure to a substance without suffering the ill effects or the disease caused by that pollutant. When it comes to carcinogens, there's no evidence of a threshold level for these types of pollutants. So, the threshold level is more so related to toxic materials. And so basically you can see that the longer time of exposure means that the lower concentration would still result in a harmful effect. So if the time of exposure is reduced, the acceptable levels of concentration of a chemical can be higher. And that's an important concept when it comes to managing hazardous wastes. So hazardous materials are chemicals that present a certain hazard or a risk, and the EPA classifies them according to their ignitability. So for example, gasoline would be a hazardous substance. Corrosivity, so any kind of acid would be also a hazardous material. Reactivity, which means that they may explode or create toxic fumes, and their toxicity as well. So this would be substances that are harmful when they're eaten or inhaled. Radioactive materials are considered to be the most hazardous. When we think about exposure to toxic chemicals and hazardous materials, we need to think about the total product life cycle, as we saw in the earlier module. Chemicals can enter the environment at every stage of that life cycle. So there can be emissions associated with the extraction stage, the refining of raw materials, the use stage, transportation, and end use and final landfill pollution resulting from disposal of those materials. All right, so we need to think about the entire life cycle when considering exposure to hazardous materials. Hazardous waste disposal is regulated under a variety of acts, including the Clean Air and Clean Water Acts. So those two regulatory acts, they ended the disposal of hazardous waste into the air or the water, which in turn caused the companies to start practicing unregulated land disposal. Especially in the 1970s, there were numerous land disposal methods that were used in the United States, such as surface impoundments, landfills, and deep well injections. These three categories are still methods used for disposal of hazardous wastes. And however, they're more strictly regulated nowadays. But in the 70s, without regulations or enforcement, groundwater contamination was quite common. So just looking at an example of one of those strategies for managing hazardous waste, surface impoundments. So these are excavated ponds that hold the waste. They're inexpensive and they're also the most widely used form of managing hazardous wastes. Essentially, this is a way of disposing of a large amount of water that carries a relatively small amount of chemical waste. Those wastes tend to settle out, the water evaporates, which further concentrates the chemicals. These facilities can receive the waste indefinitely for an indefinite amount of time, as long as the bottom is well sealed and if the evaporation rate equals the input of waste. So if the same amount of volume is being evaporated each day as what's being received by the facility, then they can continue to receive the waste materials indefinitely. However, there's always possible problems associated with these facilities, like overflowing or leaching into groundwater. And then the evaporation can also add to air pollution. So getting back to just general municipal solid waste, and also including the hazardous waste component, the fate of the waste that's collected and managed is very different in different settings. So in lower and middle income countries, more resources are spent on the collection of wastes, and fewer funds are available to invest in modern waste disposal methods. Urbanization increases these waste problems. So this is an serious problem, environmental problem in many countries that are developing or that have entered into the middle income bracket. For higher income nations, these countries tend to spend more resources on waste disposal. They often ship waste to poorer nations that have fewer environmental laws and less worker protection. So this is an important problem that needs to be addressed. And historically, in the US, hazardous wastes have been mismanaged, leading to numerous sites that are now contaminated and referred to as Superfund sites. So Superfund sites are those that appear in the final national priority list. And you can see here that the majority of these sites are still currently on that list. Few of them have been deleted from the list or cleaned up or remediated. There are several new sites that have been proposed to be added. So there's a huge backlog in terms of the number of sites that are contaminated with historical pollution of hazardous materials, and the funding for this type of remediation project is often hard to come by. So the government funding that was allocated ran out, and a lot of times the states don't have the resources to dedicate to completely solve these problems. So it leads us to the situation we're in today, where a number of these sites are still out there on the list and not able to be used for any productive activity. And there's an important consideration for environmental justice when it comes to hazardous waste management and sites that have been contaminated by hazardous wastes in the past. So for example, the largest commercial hazardous waste landfill in the US, located in Alabama, is in a community that has 90% of the population, which is African American. And another situation in Arizona, the Navajo Nation is exposed to dust containing uranium, radium, other radioactive materials, and some of those are derived from mining operations that were operated under government contracts in the past. Another example, you have almost 1 million federally subsidized housing units that are located within 1 mile of factories that emit toxic emissions. So environmental justice refers to the movement that seeks to end the disproportionate burden that communities of color and low-income communities are experiencing when it comes to environmental pollution. So when trash and when other waste materials escape the ideal management system, if they're not disposed of properly, if they're not managed properly, they can cause severe environmental problems, especially if they reach beaches or ocean water. So there is this phenomenon of garbage patches, which perhaps may have heard of. The currents in the oceans move the floating plastic into these large gyres, or basically like islands of trash. The plastic from those islands can leach or absorb chemicals. The trash can entangle animals and can be mistaken for food. So there's not only social consequences of hazardous and municipal solid waste mismanagement, but there's also serious environmental and ecological hazards associated with these waste materials. So there's several garbage patches that are present in the different oceans of the world, as you can see in this figure here. When it comes to waste management, the US EPA has established a hierarchy which consists of the following 4 approaches. So the least preferred approach is treatment and disposal of waste. A little bit more preferred is energy recovery, like the example of Sweden. Even better would be recycling and composting of waste. And then the most preferred approach, according to the waste management hierarchy, is source reduction and reuse. So let's start with the first approach, the least preferred approach, which is management and treatment. So treatment and management of municipal solid waste and also with some hazardous waste can be done using landfills. Landfills are an engineered system where waste is put on or in the ground and then covered with earth. And these landfills would have an impermeable membrane that prevents the leachate from the waste from contaminating groundwater, although there are still instances where the leachate will leak out from the landfill and contaminate the groundwater or contaminate surface waters. The other problems, as mentioned before, related to environmental justice are that the landfills have often been historically placed in or near low-income neighborhoods. Another problem associated with landfills is that the waste decomposes anaerobically, which produces a biogas that contributes to global greenhouse gas emissions, in particular with the emission of methane. So this methane can seep through the soil. It can also cause explosions. However, if designed properly, landfills can be set up to capture, purify, and use the methane as a fuel source. So there's opportunities there for resource recovery. So a modern landfill looks like you can see here in the figure, looks like this. You've got a plastic liner and a leachate drainage system. On on the bottom of the landfill, also with a layer of compacted clay, gravel, and compacted dirt. So any water that ends up entering the landfill starts to trickle down, or moisture produced within the landfill trickles down and becomes leachate, and that leachate is collected at the bottom of the landfill. It's often recirculated and pumped back to the surface and allowed to continue to circulate through the landfill, which helps keep the material moist, and that helps with the anaerobic decomposition of the waste. You've got a series of cells which are stacked up on top of each other in different lifts, and each day the cell that's being used for that particular day is covered with a layer of soil. After a cell is complete, it's covered with a thicker layer of soil and then sealed off, and a new cell is started. So once these cells are completely used up, then the entire landfill is covered over, and there's a period of time where it's allowed to remain there with groundwater monitoring, biogas recovery and capture. And after a longer period of time, the land on top of that landfill can be reclaimed and reused for different development purposes. For hazardous materials, those are handled in special landfills called secure landfills. So in 2013, almost 650 million pounds of hazardous wastes went into landfills. And these secure landfills are specially lined. They have special linings that are more robust than the ones used in conventional landfills. The leachate is removed and handled appropriately, and they are monitored very carefully and properly capped when they're filled up to the top. So these are considered a safe and appropriate treatment technology or management technology for hazardous waste in the United States. When siting a landfill, there's certain considerations that should be taken into account from a design perspective. The first is the presence of wetlands, surface water, and groundwater. And so you want to minimize the impact that the landfill has on the groundwater, surface water, and other water sources. You also typically would conduct a traffic impact study because there will be daily trips being made by garbage trucks, and so that will contribute to local traffic and air pollution. You have to, of course, maintain consistent with any land use, environmental laws and regulations, and then also consider environmental justice impacts. So not siting the landfill in lower income communities exclusively, or being very conscious about where those landfills are located related to the population. Now, waste to energy facilities, this is one tier up from landfills on the EPA hierarchy. So in these facilities, municipal solid waste is combusted at high temperatures. This reduces its mass and volume, but it produces ash as a byproduct. And of course, the heat that's generated from this combustion can be used to produce steam with a boiler. And then that steam can be used to generate electricity. So that's how the waste is converted into electricity. In the US, there's approximately 84 of these facilities that burn almost 30 million tons per year of municipal solid waste. The combustion reduces the weight of municipal solid waste by approximately 70%, reduces the volume by approximately 90%. There's two different types of ash that are produced. The fly ash contains toxic substances and requires disposal in secure landfills. The bottom ash, however, can be used as fill in construction, or can be converted to concrete blocks and reclaimed, reused in development. There's different challenges associated with waste to energy facilities. For example, air pollution and odor are a concern. Scrubbers can be installed to treat the air before it gets discharged to the environment, but some of the pollutants might still cause an impact, and especially in facilities where scrubbers are not installed. These facilities are also expensive to build, and they're difficult to find an appropriate site, as with landfills. But this is what a modern waste to energy facility looks like. So you've got the material processing, and it first gets discharged into a pit. From there, it gets added into a hopper that feeds it into the combustion chamber. There you can see the bottom ash is collected and can be used, separated into metals and aggregate materials that can be used in construction. The other ash is fly ash, which gets collected in the final chamber and has to get managed using a series of environmental controls due to the toxic materials that it can contain. So the boiler that produces steam using the heat that's generated during combustion, that can be used to power a steam turbine, which then drives a generator, which produces electricity. All right, so the end products there you get are water that needs to be desalinated, water vapor, carbon dioxide emissions. You also have fly ash, which needs to be sent to a secure landfill, and you have metals and aggregate materials as end products. When it comes to siting landfills and waste energy facilities, for landfills, the number of landfills in the US has actually decreased since 1988. So a number of facilities being decommissioned, and new facilities are not really being constructed. So according to the US EPA, there's not a concern about capacity in our landfills. And it's difficult, like I said, to build new landfills because people generally don't want these facilities close to them. So finding a suitable site is quite challenging. Any potential site that's identified is likely to be met with protests and lawsuits. And this is no matter what neighborhood it ends up being located in. So you have the Lulu, locally unwanted land use. You've got the NIMBY, not in my backyard, NIM2, not in my term of office. So politicians being hesitant to take on a project like this. And then the, build absolutely nothing anywhere near anything resistance. So, everyone produces waste, but there's now there's a reluctance to have the facilities located near places where we live, work, and recreate. And definitely environmental justice is an important consideration. So environmental justice is defined as the fair treatment and the meaningful involvement of all people, regardless of race, color, national origin, income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. And this is an important consideration when it comes to the design of solid waste and hazardous waste management facilities. All right, so by fair treatment, what we mean is that no group of people should bear a disproportionate share of the negative environmental consequences that result from industrial, governmental, and commercial operations or policies. So when it comes to landfills and waste energy facilities, no particular group should bear that disproportionate share of impact. Meaningful involvement means that people have an opportunity to participate in the decisions about these activities, and community concerns will be considered in the decision-making process. And perhaps furthermore, the community should be involved in the decision-making process from the very beginning. The history of the environmental justice movement. So this is a movement that emerged from the civil rights movement. One of the first events that is considered to be part of the modern environmental justice movement is one that took place in 1979, actually related to a landfill. So a group of homeowners in Texas formed a community action group. This was a neighborhood that was predominantly African American, and there was a proposal to site a landfill that was going to be located within 1,500 feet of a local public school. And so this group of homeowners filed a class action lawsuit, which unfortunately was unsuccessful, but nevertheless set a precedent that this type of activity, this type of engineering system located in minority neighborhoods would not be tolerated. All right, so another major event in the history of environmental justice movement happened in 1991 when there was a leadership summit where the 17 principles of environmental justice were drafted. Right, so those principles are still referred to today by environmental justice groups. In 1994, President Bill Clinton signed an executive order which addressed environmental justice in minority and low-income populations. And there currently there's an environmental justice working group and activities through the Environmental Protection Agency, and so it is a movement that is still alive today. Here's a look at the 17 environmental justice principles, and this is an abbreviated version of the language in each of the principles. The full language for all 17 principles can be found in one of the assigned readings. But you can see here some of the principles that are directly related to the design and implementation of engineering systems. So number 6 there, cease production of toxins and hazardous wastes, radioactive materials, and hold producers responsible. So if you're an engineer who's designing a system that has some type of hazardous waste that is produced during the process, this is going against the principles of environmental justice. So what you might want to do is consider an alternative process that avoids the production of hazardous waste, or at least minimizes the production of toxins, hazardous waste, radioactive materials. Number 12, affirming the need for urban and rural ecological policies and having fair access to resources. Number 16, calling on education for social and environmental issues, having an appreciation of diverse cultural perspectives, so this can be incorporated into engineering design. And number 17, making personal choices to consume as little resources and produce as little waste as possible. So again, when you're designing systems, designing technologies, or engineering solutions, it means designing them to optimize the production of as little waste as possible and the consumption of as little resources as possible. All right, so another step up the hierarchy in terms of waste management is recycling, composting. More than 75% of municipal solid waste in the US is actually recyclable. However, the process of recycling these materials requires energy, and it can also produce its own pollutants through the transportation and the processes required to recycle those materials. So you've got primary cycling, which is where the material is recycled into the same product. An example there being newspapers recycled to make more newspapers. Then you've got secondary recycling, where the waste is made into a different product. And an example would be recycling plastic bottles into fleece jackets. We also have distinction between pre-consumer and post-consumer recycling. So pre-consumer is anything that's discarded before consumers use the product, like scraps from manufacturing. Whereas post-consumer recycling means materials that are discarded after the use phase. Recycling has increased in the United States drastically since the 70s, and currently is more or less 1/3 of the percentage of generation that's recycled, of percentage of municipal solid waste that's recycled. But of course, the best solution when it comes to the EPA hierarchy of waste management is source reduction and reuse. So what does this mean? This means designing, manufacturing, purchasing, or using materials so that in a way that you reduce the amount and reduce the toxicity of the waste that's produced. So one way that this can be done is by reducing the weight of items. One example is cans for food products. They are now produced with 60% less weight. And so less steel is used and therefore less waste is produced. Going paperless is another example. So computers and the internet have reduced paper waste drastically, although now you have the production of a new type of waste, electronic waste, which has to be managed and handled in a specific way. Reusing durable goods, reselling items, services like FreeCycle and Facebook Marketplace are examples of ways that items can now be easily reused and transferred to a new owner. And then one principle here, just designing products that last longer and that are easier to repair. So nowadays, we tend to have more products that are lasting for shorter periods of time. They're more difficult or more expensive to repair. And that results in this culture of buying and throwing away, buying and throwing away. Right? So we need to break out of that cycle and really seek to produce engineering designs that achieve source reduction and reuse.